So you need to make sure that you've done your bell ringer in Google Classroom, and then we're going to be talking about finding the probability of a compound event using the multiplication rule. And while you're watching this video, you should be filling in the foldable, and then you're going to do a puzzle using this method to find the probabilities. So the I can statement for today is I can find the probability of compound event using multiplication. So instead of finding the probability by making a list or a table or a probability tree, we can just use the multiplication rule in majority of the cases to help us find probability. So it's a little bit of a shortcut. Okay, so the first thing we want to talk about is we want to review what a compound event is, some examples of it, and what it means to be independent versus dependent, because that's going to be extremely important when using this rule. So a compound event is an event that includes two or more simple events, like flipping a coin, spinning a spinner. An example would be flipping a coin and rolling a die, flipping a coin twice, picking two cards from a deck of cards. So if you remember from last week, there are two types of compound events. The first is an independent event, which is when the outcome of one event does not affect the outcome of a second event, like rolling two dice, picking a card and putting it back, or picking another card, okay? So anytime you put the material back, it's independent, okay? A dependent event is when the outcome of the first event affects the outcome of the second event. So picking a card and not picking it back and then choosing another one. Because that first card's not there anymore, it can't be chosen. Okay, so keep that in mind when we're finding the different events. Okay, so what I want you guys to do now is pause your video and write down what you think about these independent or dependent events, and then we'll check them. So for each one, either write an I or a D if you think it's independent or dependent. So now that you have filled them in, we're going to talk about them because, again, it's really important when using the multiplication rule that you know whether it's independent or dependent. It changes the answer. So the first one is spinning a spinner and flipping a coin. That is an example of an independent event because you can't take anything off a spinner, so they don't affect each other in any way. Drawing a card, putting it back, then drawing another card. Since you put it back, this is another example of an independent event because now you can pick that card again. Choosing partners for an activity by pulling two names from a hat. That is going to be a dependent event because if I pull Johnny's name and then pull Lucy's name, I can't pull those names again. They're already partners. Spinning a spinner twice. That's an independent event. You can't take things off of a spinner. Drawing a marble, keeping it, and then drawing another marble. That's dependent because you kept it. You did not put it back in. So now let's talk about the rule. So how to calculate the probability of compound events. Because making a list, a tree, a table, it takes a long time. This is a shortcut. For an independent event, the events have no effect on each other. So simply multiply together the two probabilities of each event happening. So you find the probability of A and then B, find them separately and multiply them together. So like flipping a coin of getting heads, the probability would be 1/2. On the second coin getting heads would be 1/2. So we just multiply across and get 1/4. Okay? Because they're not dependent on each other. So they're independent events. For a dependent event, the first event will change the probability of the second event, so multiplying the probability of the first event by the probability of the second event after the first event has happened. So a couple weeks ago we talked about if we took a card out of the deck, what would our new probability be? So if we had 52 cards, the second time we did it, we'd only have 51 cards. So sometimes the denominator and numerator will change, but the denominator will always change. Okay, so let's go through a few examples. The first example is you roll a fair number cube twice. What's the probability of each event below? So we know that when we roll a fair number cube and another fair number cube, that's an independent event. So that's our first step. Decide if it's independent or dependent. So it's independent for all. So now we're going to find the probability. So we're basically just writing fraction multiplication problems. So the probability of getting a 2 and then a 6 on a fair number cube, there's only one 2. So we find the probability of 2 times the probability of 6. So the probability of getting a 2 is 1 out of 6. Probability of getting a 6 is also 1 out of 6. So together, that's 1 out of 36. Okay. So the next one, the probability of getting an even and then an odd, if we separate it, it's probability of even times probability of odd. Probability of getting an even is 3 out of 6. Probability odd is also 3 out of 6. So we're going to get 9 out of 36 or 1 out of 4. And if we were doing this on a quiz or a test, remember we change them to a decimal and also a percent. And then the next one is the probability of 4 and then the probability of 9. So the probability of getting a 4 times the probability of getting a 9. Well, the probability of getting a 4, just like 2 or 6, is 1 out of 6. There are no 9s on a number cube, so the probability is 0 out of 6. We multiply across and we get 0 out of 36 or 0, because there's no chance of this happening. Because if one event can't happen, neither can. So again, we're looking to see if it's independent versus dependent. So in the next example, it says you flip a coin and roll a dice. What's the probability of flipping heads and rolling 4? So again, flipping a coin, rolling a dice, nothing can be kept. So it's an independent event. So we're finding the probability of getting heads, probability of rolling a 4. Probability of heads times the probability of 4. Probability of getting heads is 1/2. Probability of getting a 4 is 1/6. So the answer is 1 out of 12. Okay. For the next example, we're doing two things with the same thing. It says each letter of the word assessment is written on a card and placed in a bag. You are equally likely to get any card. Use this setup to answer questions J and K. What's the probability of picking 2 S's if the first card is replaced before you pick the second card? So since it says this word replaced, it's independent. All right. So the first one, we're going to find the probability of getting 2 S's. So it's really just the probability of S times the probability of S. There are 1, 2, 3, 4 S's in the word assessment out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. Nothing happens. We put it back in. So we still have a chance of 4 out of 10. Which is 16 out of 100, or 4 out of 25. So our probability is 4/25, okay, or 16%. Okay. The next example says, what is the probability of picking 2 S's if the first card is not replaced? This is now a dependent event. So since the first card is not replaced before picking the second card, we're finding the probability of S times the probability of S after S. So the first probability is still 4 out of 10, but when we multiply, we don't have as many S's. It's like one of them got picked and isn't there anymore. So now we only have 3 S's to pick from and only 9 cards because one of them's gone. So we're going to get 12 out of 90, or let's see, 3 goes into both of them, so 4 out of 30. And then we could say 2 out of 15. So there's a 2/15 chance of picking an S, not putting it back in, and then picking another S. Okay. All right, the next example, there are 9 girls and 12 boys in Mr. Johnson's class. She writes each of their names on a piece of paper and puts them in a bag. She's going to draw out 2 names to decide who will be the students of the week. What is the probability that she picks a boy's name first and then a girl's name? So she's not going to put them back in. Okay, so that means that this is a dependent event. It's dependent. So we want to find the probability that she picks a boy's name times probability of girl after the boy, because she's not going to put the name back in. So the probability of getting a boy, there's 12 boys, and there's a total of 21, because 12 plus 9 is 21. Okay, but then the next time we choose, the probability of getting a girl after the boy, that does nothing to our numerator. There's still going to be 9 girls' names in the bag. But there's 1 less card, so it's 9 out of 20. Okay. So instead of just multiplying straight across, I'm going to simplify it first to help myself out a little bit. I know that 3 goes into both 9 and 21. So I'm going to get a 3 here and 7 here. And I know 4 goes into both 12 and 20. So I'll get a 3 and a 5. That makes it a little easier to multiply across. So I get 3 times 3, which is 9. 7 times 5 is 35. So there's a 9/5 chance of choosing a boy and then choosing a girl. Next example. A bag contains 3 green, 2 blue, and 5 yellow marbles. If Melissa randomly draws 2 marbles from the bag without replacing the first marble, what's the probability of drawing 2 green marbles? So it says without replacing. So because it's without replacing, it makes it a dependent event. So again, we have to take away from the second. So again, it says what's the probability of drawing 2 green marbles? Okay, so it has 3 green, 2 blue, and 5 yellow. So altogether, it has 10 marbles. So it's the probability of getting a green times the probability of green after green. So the probability of getting a green would be 3 out of 10. But now we're down a green. So at the second time, the probability would be 2 out of 9. So again, I'm going to do a little cross reducing. So I divide both of these by 2. I get 1 here and 5 here. I can divide by 3. I get 1 and 3. So then I'm going to do 1 times 1 is 1. 5 times 3 is 15. I have a 1/15 chance of getting 2 green marbles out of the bag. Okay, so make sure. So the next thing you're going to do is you're going to do a cut and paste activity where it gives you a situation. You have to determine if it's independent or dependent, and then match up the correct probability. So what I would suggest doing is I would suggest cutting out all of the word problems first, gluing them down, then deciding if they're independent or dependent, gluing those down, and then showing your multiplication problem underneath in the space left over, and then gluing the correct answer on top of it. Okay?